Assalamualaikum and hi. In this video, we will continue with the discussing the past year PSPM 2 2014-2015 question 5 and 6. Okay, first we continue with the question 5. So 5A, they already give you data about the reaction between H2O2, reaction with the Ki with the presence of acid according to the following equation. So in the question, they give you statement. Which one is right? H2O2 react with the Ki, react with the HCl by using this equation. But in this equation, you can see that the Ki, they only represent by using I minus. The hydrochloric acid, they represent by using H plus. Because this equation only show the ionic equation. So you must know that the H plus here are come from HCl. The I minus here are come from Ki, and then they give you data in the table 2. Okay, in the data they have three unknowns, J, G and H that we will calculate. And then you read the equation. The rate equation for the reaction rate is for the reaction is rate equal to K concentration H2O2 power of 1 and concentration I minus power of I. So in this question, they already give you the rate law. So in the rate law, you already know that H2O2 is power of 1, I minus is power of 1. So in this one, you already know that the overall order is second order, which the order that respect to H2O2 is first order concentration. The order that respect to I minus is first order also. Okay, and then they mention state the order of the the order of reaction that respect to Ki and HCl. So it's a very direct question. Just see in the red law, you can answer this question. State the order that respect to Ki and HCl and the overall order. So this question is direct because it already give you the red law. And then from the table 2, they show the experiment result obtained for the above fraction. So they ask you to predict the value G, H and J, the unknown given in the equation, and calculate the rate constant. Okay, so daripada sini you can see that from the first experiment, they give you rate, they give you concentration H2O2, concentration H plus and concentration I minus. So you know that you cannot find the G, H and J first before you knowing the rate constant K. So the trick in this question now, you need to find the rate constant first. You need to find the rate constant first. How to find the K? How to find the rate constant? By using the data in the first data given in the table, which is this table, which is the first row. Because in this first row, they already give you the value rate, the concentration H2O2, concentration H minus, concentration I minus. They give you complete information. So you just substitute in this rate law and then you will find K. When you already find the K, so easily for you to find the G, H and J. Okay, so if the reaction is and then we continue, if the reaction is carried out at higher temperature, so what will the value of the rate constant change? So in this last question, they ask you about the temperature. When the temperature change, what happened to the rate constant? So this one we relate with the Arrhenius equation. So remember Arrhenius equation relate between rate constant and also higher temperature. So yang last question ni doesn't dia tak guna pun data yang diberi dekat atas ni. Dia doesn't relate with the data given because the data given is not involve the temperature. But when they mention about the temperature and rate constant, so sebenarnya dia tengah merujuk about the Arrhenius equation. Okay, so this one is the answer. The order that respect to Ki, the order that respect to HCl, and the overall order. Okay, and then you can calculate K first and then calculate from the K that you calculate, you can find the G, find the H, find the J. Okay, and then based on the Arrhenius equation, we relate between P and also K. Okay, because they ask you what happened to the K when they increase the temperature to higher temperature. So rate constant is directly proportional to the temperature. Based on the Arrhenius equation, we know that K is directly proportional to the temperature. So when the temperature increasing or higher, so mean the term negative activation energy divided by RT, negative EA over RT will be high. So the K will be high. Okay, so you must know this one. So if you forgot about this one, tapi you tahu pasal Arrhenius equation this one, mungkin tak nampak lah daripada Arrhenius equation, you doesn't clearly see the relationship between K dengan T. You tak nampak lah K dengan T ni directly proportional ke inversely proportional. Tapi you semesti dah tahu factor that affecting reaction rate kan. So I confirm that everyone know the concept that the temperature increase, rate also increase. So you sebenarnya dah tahu jawapan dia sebenarnya temperature increase, the rate constant increase. So kalau you tak tahu pun, you boleh relatekan sahaja that K is directly proportional to the temperature. Because when the temperature increase, of course the rate constant will be increased. The rate also will be increased. Cuma you kena ingat lah bila soalan tu suruh relate antara temperature dengan rate constant. So means they ask you to use the Arrhenius equation. So you punya jawapan kenalah ada relationship dengan Arrhenius equation. You kena mention what based on Arrhenius equation, what is the difference, what is the variable change, which is K and T. Apa kaitan K dengan T? Apa relationship between K and T? Okay, so now we continue with equation 5b. So 5b, the rate constant for direction below is 0.0234 per second at 400 degrees Celsius. So they give you K at this temperature. So ini adalah K1 at T1. And then they give you 0.750 second at 500 degrees Celsius. So this one at T2. This one is the K2. Okay, calculate the activation energy in kilojoule per mole for this reaction. Okay, sebenarnya kalau you ingat lagi konsep dia, bila ada dua temperature, ada dua K. When we have two temperature and K, they based on the Arrhenius equation. When we relate about the temperature, change of temperature from 400 degrees Celsius to 500 degrees Celsius means we change temperature, we use Arrhenius equation. So when we have two temperature, two K, so you need to remember you must use this formula ln K1 over K2 equal to EA over R in bracket 1 over T2 minus 1 over T1. So remember this equation. Okay, so you can just direct take the value from the equation given. But you need to remember the constant R. If you forgot in the exam, you can check the constant value in the front page. The value R is 8.314 joule per mole per Kelvin. So it shows that the temperature must be in Kelvin value. So the question give you in degrees Celsius. So you must change the value to the Kelvin. So macam mana nak ingat unit dia masih tukar ke tak tukar? Tengok unit constant value. So the constant value is R, 8.314 joule per mole per Kelvin. So see the unit unit temperature given in the value R is K. So you must make sure your temperature is Kelvin. Okay, so change the temperature given to the Kelvin. So direct this question, just substitute in the formula and then you will got the answer. So you will got the answer in joule per mole first. And then you need to change to the kilojoule per mole because the unit R is joule per mole per Kelvin. So maksudnya unit activation energy is joule per mole. And then you need to change to the kilojoule per mole. If the question asks you in kilojoule per mole, you must change to kilojoule per mole. So this question is direct. Just use the formula and then change the value, change the unit temperature, you can get the activation energy. The trick is if you forgot the formula. And then you need to remember the formula ln K1 minus K2. But in the bracket, they are 1 over T2 minus T1. So the position of temperature are changed. T2 dulu baru minus T1. So remember the temperature also must be changed to the Kelvin. Okay, and then in this question also, they already ask you draw a label energy profile diagram for direction. So energy profile diagram. So we can see that the value delta H given here is negative. So they represent they are exothermic reaction. So of course, everyone know that negative delta H represent exothermic reaction. So you just draw the energy profile diagram for direction. And then for the from the energy profile diagram, you need to calculate the EA for the reverse reaction. Calculate the EA for the reverse reaction. So you will draw the energy profile diagram. So exothermic means that the energy for the reactant are higher than the product. Okay, so you akan draw energy profile diagram. So remember when you draw energy profile diagram, must label the y-axis and x-axis. So the y and axis, you label energy. Okay, the unit can be joule per mole or kilojoule per mole. So kita tengoklah value delta H kan kilojoule. So here the unit is kilojoule per mole. And then the x-axis is reaction progress. And then draw the curve exothermic. So remember exothermic, the reactant high energy than the product. And then draw the product in draw the reactant on the reactant side, and then draw the product, the molecule product on the product side, and then and then you remember the level from the reactant until the peak represent activation energy. The difference in energy between reactant and product represent delta H. And then remember the peak represent activated complex. The molecule in the peak it represent activated complex. So remember semua ni mesti ada dalam you punya energy profile diagram. Label the axis, label the reactant, label the product, label the activated complex, label activation energy, label delta H. Okay, so remember delta H, energy different between reactant and product. EA adalah energy needed from the reactant to for effective collision to occur, right? So dia mesti daripada energy until the peak. And then the question also ask you to calculate the activation energy for the reverse reaction. Okay, apa maksud reverse reaction? So on the normal reaction, ini adalah reactant. Okay, this one is reactant, this one is product. So when we say reverse reaction, so mean change. When it become reverse reaction, so ini akan jadi reactant. This one will become product. Bila cakap reverse reaction, bertukarlah kan. Bertukarlah yang bahagian product akan jadi reactant, yang reactant akan jadi product because it say reverse reaction. So reverse reaction now we just tak perlu pun terbalikkan graf ni because dia bukan suruh awak lukis energy profile diagram for the reverse reaction. Dia bukan suruh lukis tapi dia suruh calculate the activation energy for the reverse reaction. From the energy profile diagram here, calculate the activation energy for the reverse reaction. So means the product side ni become reactant and then the reactant become product. So remember what is mean by activation energy? Minimum energy required to initiate the reaction for effective collision to occur. So activation energy adalah energy yang diperlukan pada reactant, energy yang needed for the reactant to break the bond. Produce the product. So activation energy must be the energy from the reactant until the peak. So sekarang kita dah tukar bila reverse reaction, we have changed. This side become reactant. Yang bahagian reactant tadi dah jadi product kan. So now apa maksud activation energy? Adalah value daripada reactant until the peak. So means now the activation energy for the reverse reaction is from here until the peak. So means we need to add the value EA plus delta H. Okay, 150 plus 110. So negative value ni tak payahlah ambil pasal negative value ni hanya represent they are exothermic. So now we know that from here until here the value are 150 daripada soalan tadi 150 103. From here to here the value are 110. So you just add the value. So you dapatlah activation energy for the reverse reaction which is 260.03 kilojoule per mole. Okay, so you tak boleh hafal tau. Jangan hafal. EA for reverse reaction means that we need to add the EA value plus the delta H value. It's not like that. They must be depends on the energy profile diagram. Because now they give you energy profile diagram for exothermics. And then we calculate the EA for reverse reaction means we calculate the EA for endothermic reaction. Mungkin kalau soalan nak tukar, dia akan tukar. Dia bagi awak energy profile diagram for endothermic and then you need to calculate EA for for exothermic yang reverse reaction dia. So dia akan jadi lain. So yang awak kena faham apa itu activation energy. So activation energy is the minimum energy required to initiate the reaction for the reactant. So reactant tu yang kena ada energy yang enough yang kita belajar dalam collision theory. The reactant must have the total kinetic energy equal or greater than activation energy to initiate the reaction, right? So means that EA mesti daripada value reactant until the peak, until the activated complex. So sekarang kalau kita energy profile diagram, yang belah left hand side is reactant, the right hand side is product. So EA dia mesti daripada level reactant until the activated complex. Bila dia cakap reverse reaction, so kita kena faham yang produk tu jadi reactant, yang reactant tu jadi produk. So EA tu mesti dah daripada level reactant until the peak. So you tengok dalam situation yang diberi tu, you need to plus or add with the data H value. Okay. So now we continue with the question 6. So 6 is they give you the long question because ini adalah section B, the essay question. So question 6, an alkyl halide with molecular formula C5H11Br exists in various isomeric form. Okay, so they give you C5H11Br have various isomeric form. Isomeric. So draw 3 isomer of secondary alkyl halide. So you just need to draw 3 isomer of secondary alkyl halide. So draw lah 3 isomer of secondary alkyl halide. So dia dah shortkan lah daripada banyak-banyak isomer tu, you just need to draw the secondary alkyl halide. Secondary haloalkane. Only 3. And then 3 isomer, these 3 isomer undergoes dehydrohalogenation. Dehydrohalogenation, we eliminate HX. So now HBr lah. Okay. To give 4 product, K, L, M, and N. Okay, but now we cannot know which one K, L, M, and N. We just need to draw 4 and draw the structure of this product. Identify which can exist as isomeric isomer and then explain. Okay, so means first kali awak kena draw 3 isomer of secondary alkyl halide. So you will draw 2 bromopentane, 3 bromopentane, and also 2 bromo 3 methyl butane. Okay, this one is 3 isomer of secondary alkyl halide, and then these 3 isomer will undergo dehydrohalogenation. Okay, and then draw the 4 product when this compound undergoes dehydrogenation. Mungkin ada yang tertanya, kenapa ada 3 isomer tapi ada 4 pula product dehydrohalogenation. Maybe one reactant here, we produce 2 product. Okay, kan one reactant produce 2 product. So each molecules undergo dehalogenation. So dehydrohalogenation, we eliminate HX. And now HBr. So first isomer ni, when we eliminate HBr, we will form double bond here or we can form double bond here. Okay, so because of that, kita ada 2 product. Yang this side, they will produce either these 2 Mn here, and then this one also same. So the product of dehydrohalogenation for the first isomer and second isomer is same because it's straight chain 5 carbon. Okay, and then this this third isomer of secondary alkyl halide, they can produce 2 product. But you need to remember this one Br attached to the secondary carbon, so they can occur shift. So when we eliminate Br, they can occur shift to this carbon because it will produce tertiary carbocation which is more stable. Because of that, they can produce a double bond with the first carbon here or with the third carbon here. So dia ada 2 possibility product dia. Okay, so at the first, you only can know these 4 product, but you cannot label which one is K, which one L, which one M, which one N, because we doesn't know yet. So awal-awal you hanya boleh draw 3 isomer of alkyl halide and then 4 product when they undergoes dehydrohalogenation. Okay, and then we continue read the question. And then identify which can act as geometrical isomer. Geometrical tu apa? Yang cis stripe. So what is the requirement to form cis stripe? they must have CC restricted rotation on the CC double bond or CC single bond in cyclic. So ini bukanlah CC bond in cyclic kan. So CC double bond in alkene. And then each carbon on the restricted rotation must have two different group attached to it. So we can know this one tak bolehlah jadi geometrical isomer because this carbon attached to the same CH3. This one also cannot form geometrical isomer because this carbon attached to two hydrogen. Focus pada CC double bond. So this CC double bond also the carbon attached to two hydrogen. So we know that this compound cannot exist as geometrical isomer. But this compound can exist geometrical isomer because this carbon attached to H and CH. This carbon also attached to H and ethyl. So each carbon on the CC double bond here attached to two different group. So they are exist as geometrical isomer. So kita boleh tahulah molekul ni geometrical isomer. So they ask you why? Because each carbon on the CC double bond attached to two different group of atom. Okay, so kita dah jawab dah yang first part ni. Okay, now we move to the second part on the question. We say ozonolysis of K produce propanon. Tadi remember the four product yang you label four product for dehydrohalogenation. We cannot label which one K, L, M, N first yet. Now the ozonolysis of K produce propanon and C2H4. So you write the equation of this one. K produce propanon and C2H4O. Now write the chemical equation for the reaction. So bila awak kena buat sikit-sikit bila soalan panjang macam gini ya. Okay. Okay, you akan lukis propanon and C2H4. You akan lukis this part dulu. When you draw this product, you can determine the reactant. So from here, we know that this is the ozonolysis of K produce propanon and C2H4. So from here, we know that which one is K. So inilah K dia. So barulah you boleh label yang tadi daripada 4 produk tadi, which one is K. So this one is K. Okay, so lagi 3 tu kita tahu which one L, M or N. And then treatment of L with hydrogen bromide. L ni semua K, L, M, N tadi adalah alkyl. So treatment of the alkyl with hydrogen bromide will give a P. Will give off P which is tertiary haloalkane. So treatment of L with hydrogen bromide will give a P which is tertiary haloalkane. So now they give you hint which one is L. From the 4 product here, which one is L? So mula kita tahu kan siapa K, L, M, N. Tadi kita baru tahu which this one is K. Now which one is L? Okay, so awak kena tengok sini. Okay, bila kita tambah HBr to the double bond. So remember when double bond add HBr, they must use Markovnikov rule. So here, if you add HBr according to Markovnikov rule, carbon with the largest number of hydrogen will accept hydrogen. So now Br will goes to this carbon. So they will call tertiary. Because of that, I label this one L. You cannot choose this compound, these two compound become L because this carbon, they are symmetrical alkene because the number of hydrogen in this carbon are same. So kalau you tambah HBr, you will form secondary haloalkene. This one also same. If we add HBr, according to Markovnikov rule, the Br will goes to this carbon. So they will become secondary haloalkane. Because of that, in this question, they give you hint this one is L. Because they will form tertiary haloalkane when react with the HBr. So because of that lah saya label kat sini R. And this one, dia tak bagi hint siapa M, siapa N. So because of that, I write this one M or N. So you can choose lah ini M, this one N. Ataupun in this N, this one M. Okay. And then, so draw the structure of P and write the mechanism for this reaction. So means this question asks you determine L. What is L? Then when L react with the hydrogen bromide, you will produce a product P. So you need to draw the P and write the mechanism of this reaction. When L react with the HBr, produce P. So they ask you to write the mechanism from L to P. Okay, so kita akan buat mekanism lah yang double bond tambah HBr tu, mekanism dia. Which is ini P dia. So kita akan draw double bond react with the HBr. So the nucleophile which is the double bond attack the electrophile H. So dia add according to Markovnikov rule. So H will goes to this carbon and then this carbon will become plus. So they will attack the Br minus will attack that carbocation. So we produce P. So this one is direct equation because we know that C double bond C is nucleophile. So just attack electrophile and then you produce carbocation and Br minus. So the Br minus can attack the C plus. So you produce the product P. So now we finish the second part of the equation. Okay, next question. Suggest the product form when L is react with hydrogen bromide in the presence of the hydrogen peroxide. Suggest the product form when L is react with the hydrogen bromide in the presence of hydrogen peroxide. Tadi soalan dia react with the hydrogen bromide only, but now reaction with hydrogen bromide in the presence of hydrogen peroxide, H2O2. So they give you the add of HBr according to anti-Markovnikov rule. So previously we already know which one is L. So when L react with the H2O2 according to react with the HBr in the presence of H2O2, we know that they are anti-Markovnikov rule. So we got this answer. Okay, so ini cara kita nak jawab soalan long question. If the question give you long question, don't panic. Read the question one by one. Okay, read the question one by one. Maybe the question is long, but they give you hint one by one. So read the question one by one and then do the answer one by one also. Okay, macam inilah soalan tadi. Draw isomer of secondary alkyl halide and then draw the product, which is the product have 4 KLMN. Maybe you cannot label the KLMN at the first, but nanti you at the end in the progress you answer this question, you can label the KLMN. Okay, identify which isomer can exist at geometrical isomer and then they undergoes ozonolysis. So every statement in the long question give you hint. So jangan baca soalan sampai habis baru nak buat jalan kerja. Bolehlah macam gitu juga. Tapi kalau tampak soalan tu long question, so read one by one. Read by one and then come up with the information given in the question. Okay, whether they ask you to draw the isomer or write the equation and so on. So do the question by one by one. Okay, so I finished discuss the question 5 and 6 for PSPM 2014-2015.